first ever episode of our new show, Voices of the Deep. Today we'll be talking about the geological processes of our Earth. This includes the building blocks that make up our planet, as well as the geological systems that are repeating. I'm Joaquin Miguel, and today we'll be having a brief exploration into the geological processes of our planet. But first, do you guys have any idea what the geological processes are? Well, these are the motions in our atmosphere that shape the physical properties of our planet. Anyways, let's start from the foundation of geology, rocks and minerals. How can rock-forming minerals be identified by their physical and chemical properties? Well, there's multiple characteristics to identifying these rocks. Color is one of them. It is the most obvious characteristic of a mineral and has a variety of colors. Next is their crystal form. Some minerals have a distinct shape that are immediately recognizable. For example, quartz crystal is a six-sided crystal that you can easily recognize. Hardness is one of the most important characteristics in identifying the minerals, and it is a measure of their resistance by scratching that contributes to the formation of different types of rocks. Luster also helps us to identify minerals by looking at how they reflect the light on their surfaces. Lastly, their chemical property, solubility. Solubility refers to the ability for a substance to dissolve at a specific temperature. Some minerals dissolve in water or other solvents. Next is their melting point, which refers to the temperature at which solid turns into liquid. Minerals like quartz have a high melting point at above 1670 degrees Celsius. Now let's begin with rock cycles, an important process that emphasizes how rocks turn through one type of rock to different types of rock. Let's go to Alex and Juliana to see what they're doing in their science experiment.
Here in our free time, our teacher asked us to research the different types of rocks, so we are working on it.
So I'm here to interview. Can I have your permission to ask about your science research?
Sure.
Okay, Alex. So based on your understanding, what are igneous rocks and how are they formed?
Well, igneous rocks form through the cooling and solidification of a molten rock material, known as magma or lava.
The melt originates deep within the earth, near the active plate boundaries. Magma from the deeper sources can hit the surrounding rocks to their melting point, and if they reach the melting point, they slowly reach the earth's surface, and some of the remains are trapped below.
Oh, I understand. But I heard that there are two types of igneous rock. What are they?
Yes, you're right. Igneous rocks are divided into two groups, intrusive and extrusive rocks. Intrusive rock is the primary rock, meaning they are formed first, before the extrusive. If the magma cools slowly beneath the Earth's surface, meaning the individual mineral grains have a very long time to grow, and intrusive rocks have a coarse grained texture, for example, diabase, diorite, gabbro, granite, and peridot.
So let's talk about the formation of sedimentary rocks. Geologists said that sedimentary rocks are formed through the process of erosion and weathering, deposition, compaction, and cementation. Now, sedimentary rocks begin with weathering and erosion. This weathering process breaks down the rocks into smaller pieces by physical or temperature changes and chemical change or acid rain processes. Erosion is then transformed by natural forces like wind, water, and then after these tiny rocks are transported, decomposition occurs. Then, the sediments are deposited into layers in various environments like ocean, river, and lakes over time. As more and more layers are being deposited, the weight of the upper layer compresses the lower layers. It is called compaction. And if it finishes the process, cementation begins to form a rock.
Why do sedimentary rocks form?
The formation of this rock is a natural process of Earth's surface such as weathering and erosion, deposition, compaction, and cementation to form a new rock.
Okay, thank you for explaining. I understand it. But I feel like something's missing.
But what is that?
Isn't there one more type of rock?
Oh, metamorphic rocks are formed through the pre-existing rocks. Igneous and even sedimentary rocks are transformed into new types of rocks. So this transformation occurs when the pressure and temperature increase or chemical fluids that can cause to change the texture and mineral decomposition of original rock. There are two types of metamorphic rocks. There are foliated and non-foliated metamorphic rocks. So foliated rocks have a layered appearance due to its exposure to heat, And pressure in it aligns the mineral grains because of the pressure, for example, shale, slate, phyllite, schist, and gneiss.
But how can we identify the difference between the igneous and metamorphic rocks?
By looking at their appearance, we can easily see the difference of these rocks when we observe their physical formation, appearance, and even their characteristics.
Fascinating. I would like to thank you guys for your patience and cooperation as I interviewed the both of you. See you guys and thank you again. Now, dear viewers at home, don't leave yet because in our upcoming topic, we'll be talking about stress in rocks right after this commercial break. See you.
Energize with Milo every day and do champ.
Breaking news! There's a magnitude 4 earthquake happening right now. Speaking of earthquakes, aren't earthquakes mentioned in our episode? Let's talk about that now. Okay, maybe not right now. I'll move to a safer location. In the meantime, you guys take the commercial break.
Energize with Milo every day and do champ moves like James. Energize! Start your day the champion way. Healthy energy, energy got the energy got. Drink Milo every day. Milo every day.
Welcome back, everyone. For now, I've moved to a safer location, so let's continue on with the show. While we're on the topic of earthquakes, let's talk about stress. No, not the stress you feel before taking an exam. No, the stress in rocks. Stress is simply the force applied to rocks that causes deformation. Namely, there are three types of stress: compressional stress, shear stress, and tensional stress. Now, how do rocks behave under these different types of stress? Firstly, we have compression stress. This type of stress is most common at convergent plate boundaries. It happens when a rock is pressed or squeezed together into itself. This causes rocks to fold or fracture, and tectonic plates plow into each other. Due to this, the rocks deform or crumple as a result. An example is in Chile, where the Nazca and South American plates are smashing into each other. Next is tensional stress. This is also called extensional stress, and is the major type of stress in divergent plate boundaries. It happens when the rock is pulled apart in opposite directions. The tensional forces pull away from each other, resulting in what we call strain that stretches thin rocks. Tensional stress also causes rocks to lengthen or break apart. It can also occur in an existing plate if the certain plate begins to split into two pieces. An example of this is the Mid-Atlantic Range, where the plates carrying the North and South America continents are moving west, while the plates carrying Africa and Eurasia are moving east. Lastly, let's move on to shear stress. This type of stress is common at transformed plate boundaries. It happens when two plates are sliding sideways past one another. Friction between the plates grinding past one another creates stress. An example of this is the strike-slip fault, also known as the San Andreas fault in California. After tackling the behaviors of rocks in different types of stress, let's have a brief explanation about plate tectonic theory and its contribution to Earth. What are plate tectonics? Well, according to National Geographic, it is a scientific theory that explains how landforms are created as a result of Earth's subterranean movements. This transformed the Earth's sciences by explaining many phenomena such as earthquakes. The Earth's lithosphere comprises a number of large tectonic plates, which have been moving slowly since 3 to 4 billion years ago. The model builds into the concept of continental drift, developed during the first decades of the 20th century. Plate tectonics came to be accepted by geologists after seafloor spreading was validated in the 1960s. Now that the earthquake has passed, let's return to Apex Schools. Hey everyone, we're back again at Apex Schools to interview a student about the continental drift theory and what it contributes to our world. Let's head over to Juliana's classroom.
Hi, Joaquin. I'm glad that you came here today.
And thank you for taking time to answer me. Let's head to the first question. What does plate tectonic theory contribute to our world?
Because of this concept, we have an uniform idea for understanding mountain building process, rock formations, earthquakes, and volcanoes. It is also responsible for the many geological formations such as the Himalayan mountain range in Asia, the East African Rift, and the San Andreas Fault in California, USA.
That's so. Is there another theory that supports this?
Yes. I am glad that you have asked that question. But first, let me introduce you to the first theory that supports this plate's movement. First, the fossil evidence. There were some examples of the different fossils and plants that have been found in the different continents that suggest that the continents are once connected together. The second one is there are other fossils of Sinognathus and found only in South America and Africa. The second fossil is Listosaurus, were found in Antarctica and Peru. These fossils believe that it would not have the ability to swim in the ocean that gives them the idea that they were once part of a single land, just like Mosasaurus.
Wow, that was a wonderful explanation. It really felt like we time traveled to the past.
Oh, thank you. I put a lot of effort in that.
Those theories really provide eye-opening information about the supercontinent Pangaea. Too bad it got separated by plate tectonics.
Speaking of plate tectonics, let's move to fun facts about tectonic plates.
A fun fact? Can you explain it to us?
Yeah, I will, so please bear with me. This is actually fun to watch. Did you know that plate tectonics also has a huge impact on the processes of the Earth? Yes, you heard it right. Even though plates have a slow progress, it helps us to understand why and where the earthquakes occur and volcanoes erupt. First, let's come to the question. What are the different results of the movement of plates? The results vary between the different types of plate boundaries such as convergent, divergent, and transform. Convergent boundaries are plate boundaries where two tectonic plates move towards each other or collide head-on, resulting in the formation of volcanoes, earthquakes, and mountain ranges. As these two plates push against each other, the denser one sinks into the mantle beneath the other. This process is called subduction. Divergent boundaries are plate boundaries where two tectonic plates move apart from each other. These boundaries are often constructive. Destructive boundaries cause subduction, which is when one tectonic plate sinks into the mantle beneath the less dense plate. When plates pull apart, hot molten rock emerges as magma, and so new matter is added to the plates. As magma solidifies, it forms a new crust. Transform boundaries are plate boundaries where two tectonic plates slide horizontally past one another. These two massive amounts of energy build up earthquake activities which can shape the landscape over time. The perfect example of this boundary is the creation of a fault zone in San Andreas, California, because the horizontal motion creates a significant shear stress along the boundary and they got stuck at places due to friction, and if the stress becomes too much, it causes the ground to break and create a fault.
Okay, that's not bad at all. In fact, it gives me an idea that this theory is very crucial for the processes shaping the Earth's surface. Thank you for discussing the information.
Thank you for your insightful questions about plate tectonics. Back to you, Joaquin.
Thank you, Alessandra. We covered a lot, but stay tuned as we switch to our next topic.
Scientists have used multiple methods and observations to create what is known as the geological timescale. The geological timescale is the timeline and the visualization created by scientists, which shows the order of geological events within a time. Methods such as relative dating and absolute dating were used to create a timeline to show the order of geologic events within a time. But first, let's discuss what dating even is. Dating is the action of establishing the date or period of time that a certain object or event has existed or created. In geology, there are two methods of dating, primarily using finding the date using stratified or sedimentary rocks, which are relative dating and absolute dating.
Wait, hold on. What are stratified rocks? And what is relative and absolute dating?
Well, stratified rocks are rocks that consist of different layers that are separated by planes of stratification. These rocks are formed through the deposition of sedimentary rocks. Particles that come from pre-existing rocks due to weathering and erosion accumulate at a certain area. And particles of dead plants and animals can also accumulate along with these rocks. For example, these particles accumulate over time and eventually create different layers. With this information, scientists use two methods to determine the age of these stratified rocks. Now, relative dating is a method of dating that arranges geological events based on rock formation. This method does not give an exact age for a rock or a fossil. However, it does not tell us if it is older or younger than other rocks or fossils. Now, buckle up, because we will be going through the multiple principles of relative dating. There is a principle of superposition, principle of original horizontally, principle of fossil succession, principle of inclusions, principle of cross-cutting relationships, and lastly, the principle of unconformity.
Wow, I didn't know relative dating had that much principles. Now what is absolute dating about?
Absolute dating is a method used to determine the actual age of rocks. Unlike relative dating methods, absolute dating methods provide chronological estimates of the age of certain geological materials associated with fossils and even direct age measurements of the fossil material itself. There are two methods of absolute dating, which are radiometric dating and age bracketing. So, radioactive dating is the method of observing certain radioactive atoms in a rock. Radioactive isotopes break down, which is known as radioactive decay. Radioactivity always affects atoms in a predictable way. The rate of change or decay in different elements help with dating different age ranges.
Now, the other method is called age bracketing. Scientists look for clues and data that can show the possible minimum and maximum ages of sedimentary rock layer and any fossils within the layer.
All in all, relative dating is used in arranging geological events based on the sequence of rocks, and absolute dating is used in finding the exact date or chronological estimate of the age of rocks. Scientists use both methods in creating a geological timescale using all of the methods of dating.
Wow, thank you for the interesting information you've given about the geological timescale and rock dating. Now, let's move on to the final segment of our show. Now that we've gathered and learned the information about the Earth's geological processes, let's have a quick closing quiz to review your understanding. For our first question, what are the two kinds of rocks?
That would be igneous and extrusive rocks.
Correct. Second question, what is the name of the supercontinent in which all continents were once conjoined together?
That would be Pangaea.
Correct. Third question, what are the two methods of rock dating?
The two types of dating are relative and absolute dating.
Correct. Now for our last question, what is the geological timescale?
It is time that is created from the information and data gathered from the geological records of our planet.
And that's 4 for 4. If you viewers at home got all of them correct, give yourselves a pat on the back. To wrap up our episode, let's recap what we've learned today. We tackled the foundation and building blocks of our planet, which are rocks and minerals. We discussed the different types of rocks and minerals, along with their observable qualities. We also learned about how pressure and temperature affect the rocks on our planet's lithosphere. We explored the different pieces of evidence that support Wegener's theory of continental drift, and how it connects to the movement of tectonic plates in our planet's surface, along with its effects. And lastly, we learned about rock dating, and how it's used to create a timeline for our planet. Now that you've learned the geological properties of our planet, I hope you gain a deeper understanding about the world we are currently living in. That's all for today's episode. I hope this deepens your understanding about the geological properties of our planet. Thank you for watching.